All right. So the first thing that we want to cover today is just sort of a general idea of different types of memory storage, um, electronic memory storage, both non-volatile and volatile. So this is where we'll talk about the SD cards, and we'll talk just in sort of general terms about some of the other uh, types of storage you can have. So in memory devices, and we've sort of been using the term memory and some of these other terms as we have gone on, as we've been talking about the Arduino. But we just mean some sort of electronic circuit that can store information in hardware. So, and they're all going to use some kind of digital logic to do programming operations, do different types of operations, right? And this is a very broad definition. We mean, so for example, we've mentioned that there are 3 types of memory on the Arduino previously: EEPROM, RAM, and flash memory. This also includes things like hard drives, disks, magnetic tapes, if you're old enough to see any of that. All of those sorts of things are memory devices, right? They are an electronic device that can store information, i.e. memory. On the basic level, you have to build these things out of blocks of logic gates, right? And we're not going to go into this. If you are an electrical engineer, you will become very familiar with all these types of logic gates and how you build the base building block of how you store a single bit and how you build that up. But for most of the rest of us, that's a little bit beyond where we want to get into. But on the hardware level, all of your memory is basically constructed of, these days, millions upon millions of individual logic gates, which you use to build into memory circuits. And sort of the most simplest one that are going to maybe be called latches or flip-flops. A latch is something that will hold a particular value after you remove the input signal. So like you can write the bit to a 0 or a 1, and after you remove the signal, it will maintain that value. And a flip-flop is basically you can send a pulse and it will alternate 0s and 1s, right? So we haven't really talked a lot about logic gates. I think we briefly mentioned them way back when we first talked about electronics. But these are the hardware versions of some of those logical operators that we talked about in programming, right? This is, for example, a circuit that will take 2 inputs and generate a logical output. And you can have an AND or an OR, a NOT, and then a NAND and a NOR. So a NAND and a NOR are just, they apply a NOT to the result. So you AND the gate, and the 2 inputs together, and you invert the output, right? And the NOR is the same thing except with an OR. In particular, the reason those are so important is it turns out that you can generate, you can basically build any other kind of logic circuit out of one of those types of gates. So if I have a NAND gate, I can put several NAND gates together to make an AND, an OR, a NOT, or a NOR. And similarly, I can build everything else with just NOR gates. And because you have to manufacture so many these are like the tiniest building blocks, and you have to build so many of them. Obviously they're going to construct out of the simplest possible device. Unfortunately, I do not have a good suggestion for like the most basic sort of logic circuits. I my background is not electrical engineering, so sort of what I just know what I have picked up along the way. I'm sure some of the students or some of the other instructors are background is in electrical engineering, so they may be able to recommend that. But the point is you take these logic gates and you combine them, and you can build these latches which will hold a value, or these flip-flops, and those are sort of how you would construct memory, or like the registers that we've talked about, or adders and all of that. So like I said, that's sort of beyond the scope that we want to get to in this course. We've got so much other stuff to try and learn. So in general, you sort of have two basic types of memory. You have volatile and non-volatile, and basically all that means is, does it keep the values when you turn off the power? So volatile memory, it requires a constant power to maintain the stored information, right? And that's the most obvious example of that is computer RAM, right? When you turn a computer off, all the variables that are in memory. So usually when we just say the word memory, we are talking about RAM. All of that goes away, right? So like when you cycle power to your Arduino, all of the variables get reset to whatever the initial values, sort of initial setup that you did in your program. Non-volatile memory is the opposite. It will it'll store the information even without power. And sometimes you can cheat on the volatile memory. That's why you have little coin cells in several, sort of circuits. Basically, those provide a tiny amount of power to allow you to maintain the information, because you don't really need a ton of power to just keep those values alive. So you can use something like a tiny little watch battery or a tiny coin cell battery. So that's why that's what the coin cell on the GPS does. It's basically providing a little bit of power to some volatile memory. The real-time clock that you're going to use, all of that, that information is stored in volatile memory. But if you give it a little bit of power, it can keep it on. But in general, if there's information we are recovering later, we want to put it in non-volatile memory. So, that's like the flash memory that your program gets uploaded to in the Arduino, right? The Arduino, it needs power to run the program, but as soon as you supply power, it will run whatever the last program that was stored, because it stores that in the flash memory, which is non-volatile memory. So a term that you will hear is ROM, which is read-only memory. So you used to see that more often with CD-ROM, right? But that means it's basically memory that is for storage. And the idea is that it's a fixed storage. However, there are the terms EEPROM, E2PROM, EEPROM, and EEPROM. So the E stands for erasable. So obviously, if you can erase it, you then will put new storage in it. So that is basically a type of ROM that you can rewrite, except it's a little bit more complicated than that. And usually that sort of thing is relatively slow, and there is, a finite amount of write cycles because of how these work. So usually what those are going to be used for is data that you're not going to change often. So you can have like something that's called a lookup table, which is basically you give it a number and it returns another number. And the idea is that basically like, oh, there's a bunch of fixed numbers that I don't have to change. That may be where the firmware that sort of starts up your device will be. That's sort of like the basic level software that boots up your computer or your electronic device, right? The idea being that base level is not really going to get changed. Then it will start up other pieces of hardware that will maybe read in other information and run more complex tasks. But yeah, so, and if you recall, there is an EEPROM on the Arduino. That is not really something we use in this course. It's pretty limited storage wise, but what you could use for is sort of your last ditch, like, hey, I want to be able to look up something if all of my other, if my SD card fails, but the point is it's not really quick, it's not really large, so you want to limit it to small, very vital information in general. Flash memory is sort of the catch-all term we use these days for solid state storage memory, right? So this is, what your USB thumb drive is made out of, what the SD cards are made out of, the actual memory that we call flash memory on the Arduino, which is where the program is stored, right? And flash memory is sort of relatively modern as far as these things go. Like EEPROMs were, common back in the 80s. Obviously, they're still used, but it's only in the last, 10, 15 years where flash memory has become a viable method of storing large amounts of data, right? If you're older, you may recall, back when we had to use like floppy disks and zip disks and stuff like that. These days, why would you ever have that when you can just have a flash memory USB drive that is way larger? But that is a product of the cost and manufacturing techniques improving, the cost decreasing and the manufacturing techniques getting better so that you can build these things to store gigabytes and terabytes of data. So in general, flash memory is non-volatile memory that can be erased and reprogrammed. Technically, the tricky thing is that flash memory is a type of EEPROM, but sort of colloquially, you will use the two terms differently. EEPROM is usually referred to something that's made out of NOR gates, and flash memory is made out of NAND gates. But that's because those two techniques generate types of memory that is good at different things. Basically, EEPROMs are good for small storage where you would want to individually rewrite single bytes, whereas flash memory is much more scalable. But if you're going to like overwrite something, you have to basically overwrite it in big chunks. So that's why you may see term like sectors or pages. And that's because in flash memory, you have to do this sort of, I'm erasing all of this chunk of data at the same time. So because of that, flash memory nowadays is good for building large storage where you don't have to worry about the individual little like, oh, I'm going to lose this little bit. Well, I'm erasing all of that. And, if I have a little bit of wasted storage because I have to put everything in these big chunks, I don't really care. But there are, limitations because of that, so usually like solid state hard drives and SD cards and USB drives, they're all going to be flash memory. They're all going to use this NAND gate technology on the basest level. But in general, the terms are not really like, there's not a really good technical definition of this is flash memory, this is EEPROM. It's sort of, if it's a small amount of storage, it's probably going to be called an EEPROM. Where if it's a big giant thing holding several gigabytes, it'll probably be referred to as flash memory or flash storage. RAM is the other. So these are all the, sort of the three types of storage that we have on the Arduino. And they're sort of general, the three types of storage you have in, other electronic devices and computers. RAM stands for random access memory, which is, it's volatile memory. That's where you store all of your working data, your program, and your variables while it's running. The random access means that you can go, the random access part is just basically being able to go to a random point, a random address in the memory. So I don't have to read it starting from the top, going all the way in order. And that's useful for programming because it allows you to basically dynamically allocate variables and say like, oh, this data is going to be sitting at this address in the RAM. And also it's generally, this is going to be very quick read and write because this is actually what's talking directly to the CPU. This is where we're doing like CPU math operations, so we want it to be fast. But the problem is, one, it's going to be much more limited in size, right? Even a very high-end computer these days, you'll maybe have like 64 gigs of RAM, whereas your actual like storage drive will be terabytes. But this is where your active program and software and variables are all stored while you're using it. In particular, these days it's a lot easier to just have a solid state drive, but a lot of you probably in your own computers probably still have a magnetic hard disk, right? Which has magnetic platters that are spun, and you store the data in the magnetic field on all these little metallic platters that are inside it. So magnetic hard drives are great for storing large amounts of data, and for for a long time, they were basically the only viable way of storing large amounts of data. It used to just be too expensive to make flash memory, right? And also there were reliability issues with a lot of older solid state storage technology. But as all of that stuff has become much cheaper and much more reliable, it started to compete with magnetic hard drives. In particular, magnetic hard drives are bad for ballooning because they do not really work well in vacuum, because you have to have such tight tolerances between the lever that reads the data off those spinning disks. If you now draw a vacuum in that, well, now it'll slightly shift that and it will crash into the disk. So the way that these work is you basically have, a ferromagnetic material on a disk that spins called a platter, and you have a little reader on the end of a lever that's called a head, and it will go to different spots on that spinning disk, and it'll read or write the data. Like I said, this is pretty much used for storage on computers. And even these days, if you need to store a large amount of data, this is how you're gonna do it. Right now is when you're just starting to get terabyte solid state drives, and they are pretty expensive. Whereas if I go by, I can easily go buy several hundred terabytes of storage in magnetic drives for a significantly lower cost. But it has some disadvantages. It's slower to read and write. And it has moving parts, which if something has moving parts, that means it has moving parts that can potentially break, which is always going to be an issue with any sort of design. So the thing that we're primarily going to use for data storage in this program is our SD cards. So SD stands for Secure Digital. So it's a type of non-volatile storage device, right? It's a relatively it's sort of the latest in a long line of solid state storage devices. Obviously, most of you, I would think most of you are familiar with having a little thumb drive, a little USB drive. There was something called compact flash before this. And so, but SD cards are very common these days, particularly micro SD cards, which are the smallest size. But all they are is they are a chunk of flash memory, and you can store a large amount of data in a very small physical size. In theory, you can get them anywhere from 512 megabytes to 1 terabyte, but I would imagine you'd have a hard time finding some of those 512 megabyte cards these days, just because they're older, and who would want something that small? And these days you can get a 32 gigabyte card for 10, 15, 20 bucks. So you'll see them marked with these symbols. So SD, SDHC, SDXC, SDUC. These are sort of, so like this was the original standard, and it had to, these are all just basically trademark industry group standards saying that if you build a SD card and you want to put this logo, you have to meet these standards. And this is just increasing as they've had bigger and bigger sizes. You put newer requirements on, storage size, read write speed, and how these things operate. In general, the difference between those cards is not going to be relevant for the Arduino that we're going to be using. So this is sort of physically, if you look at the bottom of these cards, what they look like. And they come in a few different form factors. So technically, the big one is an SD card. This next size down is a mini SD, which is fairly uncommon. What you'll see a lot of is micro SD cards these days, which is the smallest size. Those fit very well into phones, game consoles, other portable devices. These are nice and small. They're about the size of a pinky fingernail, right? And hopefully you should all have those. So really, what you're most likely to see these days is an actual micro SD card, the actual storage, and then the adapter that is SD sized, because we like, these small devices are really good to use, but also making the slots, one, if I make the slot sized for this, well, there's adapters for all those other sizes, so I can just use that. I can use an adapter and put a smaller one into a bigger slot, but I can't put a bigger one into a smaller slot. So, and in fact, the SD cards that you guys should have gotten will actually be a micro SD card, and they'll come with this full-sized SD card slot adapter. So you can see there is a slight variation in the pinout depending on which size. So in particular, the micro SD only has pins 1 through 8. Whereas the full-size SD, you have an extra pin 9. And then on the mini SD, you have 9, 10, and 11. That doesn't really impact us here. Obviously, we're using the smallest number of pins. But just be aware there is a difference. Now, what may affect, well, what can affect us is what file system is actually on the SD card. So an SD card or any sort of storage device, a hard drive, a magnetic hard drive, a thumb drive, they all have to have what's called a file system, which just is basically how is the information on that storage device organized. So how does the computer know this is where this file is, this is how big that file is? So all of that, in the way that that's organized, is what's called a file system. In particular, the file system will set a maximum limit on the total size that you can store on a storage device, and the single, how big a one individual file can be. And that's because obviously I need some sort of addressing where I'm saying, hey, file 1 is from this address to this address. So as I get bigger and bigger storage size, I need to have longer and longer addresses, which means I have to have a more amount of information set aside for the file system itself. So for the SD cards, what we should see is pretty much some variation of what's called the file allocation table, or FAT file system. And in fact, these are going to, so in fact, the number here, I believe, is basically how many bits the addresses are. So FAT16 is the oldest file system. It's going to have the smallest file size. You're probably not going to run into that unless you go looking for a very small SD card, like a 2 gig SD card, or, if you can find one of those 512 meg SD cards. What you will be using, so we sent you guys 32 gig SD cards, and those should be using the FAT32 system. If you get a real big SD card, like a 64, a 128, or a 1 terabit SD card, that will use the exFAT system. And you can see here on a table, this max volume size, that's the limit of how big of a storage volume you can have in each of these systems. And then there's also a limit on how big of an individual file can be. And you can see in particular for the exFAT, the limits are really big. So a petabyte is the next. So a terabyte is one step of a gigabyte, and a petabyte is the next size above that. And an exabyte is the next factor of 1,000 above peta. And you may notice it's weird that the exFAT, you can actually have the file size limit is larger than the volume limit. That's just a weird fact of that system. I believe that's mainly because for the compatibility of this file system with other file systems, so that the actual file system, the actual system used on individual files is similar for other file systems. But so one thing that's important is basically that file system has to be handled and read in the Arduino's RAM if you're gonna if you're going to use it. And because of that, as I get bigger and bigger file systems, that means the version of the SD card library that I'm going to use with those is going to take more space in RAM. And in particular, the SD card file size, SD card library size can take a significant chunk in RAM. So most of this programming that we have done previously, you'd have 2 or 3 variables, and you'd basically be barely touching the amount of RAM that the Arduino has. You'll see in the activities we do today that basically the SD card library itself is going to eat up like 10-15% of the actual Arduino's memory. So one thing that you are probably going to want to download is the formatting utility for the SD card. So this is the utility from the actual SD Trade Association, right? The people who set the standards. It's an industry association. So this is software you can use basically to overwrite the SD card if something goes wrong or if you want to erase it. So if you click on the link here, so you're going to want to follow that link either by downloading the PowerPoint or the, can I actually pull it up? There we go. And if I now share my screen so you guys can see where this will take you, right? This is going to take you to the website where you can download this storage. So SD card memory formatter. Here's all the compatible versions, but the point is you want to go down and you want to download the appropriate version for whatever operating system you're using. And you want to install it on your computer. Right. And what this is going to allow you to do is basically completely overwrite the SD card. You may get corrupted files and stuff like that. Most of the time, you can just delete all of the files manually. You can just plug it into your computer, go into the drive, and delete all the files. But it's generally useful to have this. So what will happen is when you put the SD card into the slot or your adapter, it should show up on this little drop-down menu. This should not let you, select like your C drive or your home drive. It should just only have SD cards in here. When you do that, it'll, tell you what type of SD card it is. So it'll have that SD or the SDHC or the SDXC. It'll tell you how big the storage is. So in particular, this was a 32 gig SD card. You will see that it does not have a full 32 gigs of storage available. Some of that is that's largely due to the actual space taken up by the file system. And then you'll have some options here of being able to format it to erase it. You'll have a quick format and or an overwrite format. So when you format an SD card, it will automatically pick the file system that's the right file system for that size. This is important to note because, like I said, or I haven't said it yet, but not all SD card libraries will work with all file systems. So you can see here, I basically had formatted a 32 gig card, and it told me that it set up the FAT32 file system, and it will run through the capacity and how much size it is. There will be some other information. I could give it a volume label, so that's just what it would, like a name it would have when it gets plugged into a computer. And for example, if I instead of doing a 32 gig card, I do a 1 terabyte card, right? It'll get formatted as exFAT because it cannot fit a 32 gig card or a 1 terabyte card. And like I said, the actual file system supported by different SD card libraries is going to be different. And in particular, I'm mentioning this because the SD library that we're going to first introduce you guys to, it will not work with an exFAT file system. So the SD cards that we sent you should be 32 gig or FAT32, and you should be able to format them as that. But if you try using a larger SD card with the particular SD card library that we're going to start out with, it won't work. Now, there are SD card libraries that do work with the larger cards. It's just they're a little bit more complicated to use, and we basically selected a simpler, older SD card library because it's a little bit easier for you guys to start learning on. So the other two options that you can see here at the bottom, there's a quick format and an overwrite format. Quick format is basically you just mark all of the memory spaces free. You don't actually erase anything. So it is in theory possible to go recover that data. Whereas the overwrite will actually write values over all of the data and erase it. So consequently, quick format is quick and overwrite takes a while, particularly with a very large card. So another marking you'll see on these SD cards is what's often called a class marking. And that's basically going to refer to a write speed minimum that they have to meet. If you're using an SD card to like shoot video, right? If you're shooting HD video, you're having to write a lot of data very quickly. So there's these standards that basically say that, oh, if I have a class 10 SD card, it will be able to write at least this fast, or a ultra speed class 3 or UHS, yeah. And then I believe this V stands for video, and I want to say that's like 90 megs per second is what the 90 is. You can look this up if you're really interested, but all of these speeds are going to be way faster than you can actually achieve with the Arduino. So it's not really something we need to be concerned about for the payload we're going to be developing. But depending on what sort of applications you may be looking at in the future, or maybe if you add like a some cameras to your payload, you may need to be concerned about that.